In this lesson, we'll talk about object dimensions and scene scale. So we've got our car that we've imported into Houdini here, and we were just noticing that the size of the car is quite a bit larger than the actual construction grid. But that doesn't really tell us how big the car is. If we make a default box, let's do that now. We'll just hold Control and click on Box. And as we know, that'll create a box for us right at the center of the screen. I'm going to home the camera, so spacebar and H, so I can see my box. Now I can see my box here, and I can see that my car is way bigger than the box. But I still don't know exactly how big that box is. If I want to see how big that box is, I can get that information by diving inside of its container over here. So I can double click on Box Object 1, and if I highlight the box node that actually creates the box, I can see here that its size is 1 by 1 by 1. But 1 what is the question? That could be anything. It could be inches, centimeters, feet, miles. I have no idea. Well, actually, I do have an idea. And I know that because I can tell by looking in the preferences for Houdini. Now we're going to go to that menu here in Edit, Preferences. And I'm going to come all the way down to HIP File Options. Okay? So we'll just click on that, and that'll bring up this dialog box. Now this dialog box is where we set all of the units that are measured inside of Houdini. You'll notice that by default, the unit length is in M for meters, and the unit length is 1 meter. So what that tells me is that my box is 1 meter by 1 meter by 1 meter. Now you do have the option here inside of this dialog box to change this over to feet or yards or miles or whatever might be more appropriate for what it is that you're working with. But I highly recommend that you leave this at the default of meters and do the conversions that you need in a calculator or on a piece of paper or somewhere else. So if you need something to be exactly 6 feet tall, you can go online easily and just type in the meters to feet conversion, and it'll tell you exactly how big that is in meters. And I say this because the default of Houdini is meters. So anybody that you may hand this file off to will be expecting it to be in meters. If you're working in a pipeline with other Houdini artists, they may have their scenes set to the default of meters, just like you would expect, but you've changed yours to something different. So for consistency's sake, I would keep everything at the defaults as far as length and weight here. Unless you've been instructed to, like, very specifically by your supervisor or somebody else, then I would probably just work in the default of meters. And like I said, if you need to convert something over, I would do that just outside of Houdini and use the meters here inside of Houdini. So I'm just going to accept that. So what that tells me now is that I've created a box, and my default box is 1 meter by 1 meter by 1 meter in size. And my car is gigantic right now. But what does that even really matter? I mean, if I render this scene, I'm going to render it. It's going to show me exactly this car. It doesn't matter if it's really gigantic or really small. Well, I want to show you a series of a few videos and see what we can learn from those. So this is a scene that I created inside of Houdini, and it's just simply a wall that is shattered and it falls to the ground. And here is the same video. But you'll notice the dynamics are just a little bit different. It took just a little bit longer to fall, and pieces are falling a little bit longer than what they did before. You're getting some more motion after the initial fall, initial collapse. Here's another one. Now again, we're working with that exact same dynamic simulation. Nothing has been changed about the dynamics or the simulation in any of these videos. And finally, we have this version here, which is very slow to fall. It's very kind of sluggish and looks a little like it's maybe in slow motion or not very realistic. Let's look back at the very first one we saw, and here's the very last one that we saw. Now, when you look at the two of those together, you can really see a significant difference. Like I said, the first one looks like it happens very quick and it's really bouncy, and this one seems to just kind of take forever, like it's very sluggish. Well, it's not actually sluggish or faster or slower. What's actually happening is the size of the box is what's changing. So here you can see I have this little reference set up that the initial wall that shatters is approximately 2 meters in height, or 7 feet tall. And we have the default biped rig in Houdini here just as an example to give you an idea. So here we have a 2-meter wall, and we see its collapse. That was the first one that we looked at. Now, the next one that we looked at was a 4-meter wall collapsing. And when you see these in reference with these references with them, they don't really seem sluggish or slow anymore as much as you actually start to understand the scale of the scene. So the dimensions of that box, whether it's actually 1 by 1 or 2 by 2 or 16 by 16, really does make a difference in the way that the simulation plays out on screen. So when you see that final one again, and you realize that it's actually the height of what is the equivalent of 2 skyscrapers tall, and you can see here on the left our human reference all stacked up, you really do get an idea of how big this simulation is. These don't necessarily fall slowly anymore as much as they fall to an accurate scale depending upon the size of the chunks. So there's the first one again, and here's the very last one. So knowing that that scale is different, the simulations really seem to make sense whenever they're set to the correct scale. So I'm going to stop this here, and we're going to go back to Houdini for a second. Now, all of those videos are actually included with the project file if you wanted to go back over them and study them and try to understand a little better how the motion behaves and see if you can pick out which ones are which. I kind of like to use them as flashcards, if you will. You can just kind of look at the different videos that don't have the references in them and see if you can pick out exactly what the scale is for those, give you an idea, train your eye to look a little bit better at motion for things like dynamics. So back to our car that we have imported here. I know because I spoke with the modeler of this particular vehicle how big this car is supposed to be. I know for a fact that the dimensions of this car are supposed to be 4.4 meters by 1.24 meters by 1.92 meters. Okay. Now, I'm just going to make a quick little reference of that. So I've got that written down here, and I know exactly how big I need to make it. Okay. So one way that we can size this model up so that it is the exact right dimensions is to create a box here that is the dimensions that we need, then scale the car down so that it fits inside that box. So let's start off with our box object here, and we're just going to change the dimensions of the box object. So if we're working in the same direction here, our Z direction, which is going to run this way here, or the length of the vehicle, I know that that needs to be 4.4 meters. So I'm going to go ahead and change that. This is X. This is Y, and this is Z, so I'm just going to click inside here, highlight the 1, and change it to be 4.4. Wow, so now I can really see the scale of the car and how much bigger it is than what it needs to be. Okay, the next dimension that I need is 1.24, so let's go ahead and make the car height 1.24. We can do that here by looking at the Y parameters. So let's change the X and now Y. Let's change that to be 1.24. Okay. And now we need to set the width of the vehicle. And the width of our little template box here, that needs to be 1.92. So we'll make that 1.92. So now I have a template that tells me exactly how big my car needs to be. What I need to do now is fit the size of the car down into that box. And to do that, we're going to use a transform node. And that's what we'll start talking about at the beginning of the next lesson.